You are in a technical interview. The prompt asks you to rotate an array by k positions to the right. It sounds simple. It is actually a trap designed to test your understanding of scale. The immediate instinct is to grab the last element, shift every other item one space to the right, and drop that last element at the front. You then write a nested loop to repeat that entire process k times. On a small array, that works. But on a large dataset with thousands of elements, shifting items one by one requires massive computing power. The testing platform will immediately reject your solution with a time limit exceeded error. We can solve this using exactly 4 lines of C++ code. By applying the 3-step reversal method, we will execute the rotation in pure O1 space. O1 space means the algorithm uses a constant amount of memory, manipulating the data directly without creating any duplicate arrays. This standard 7-element array shifts right by k equals 3 when the last 3 blocks move front. But what if k is 8? Shifting 7 times returns every block to its start. That 8th rotation leaves the array exactly as if we requested 1 rotation. To handle this in code, our first step uses the modulo operator. Modulo calculates the remainder of a division. We set k equals k modulo n, where n is the array size. By calculating the remainder, we normalize the rotation count. The algorithm strictly executes necessary shifts, avoiding redundant loops and preventing out-of-bounds errors. Now we apply the 3-step reversal algorithm. This is a spatial manipulation technique that moves large blocks of data simultaneously. For step 1, we reverse the entire sequence. The target elements move front but backwards. Step 2, we reverse just that front block, flipping them into correct order. Step 3, we reverse the remaining back block into their ascending positions. The final sequences match perfectly. By breaking the rotation into 3 isolated block reversals, we placed every element in its final position without running a single element-by-element shift. We can implement this logic efficiently using C++ and the standard template library vector. A vector is simply a dynamic array that manages its own memory size automatically. Instead of manual while loops, we rely on the built-in C++ standard reverse function for manipulation. This split view shows C++ code manipulating the array. nums.begin and nums.end target the entire array for the first reversal. For step 2, we isolate the front block using begin and begin plus k. The reverse function strictly requires these exact memory iterators. For the final step, we use pointer math to target the remaining back block. Our starting address is begin plus k, and our stopping address is end. We add the final reversal command to the script, flipping remaining elements into their completed state. We have fully rotated the array using exactly 4 lines of code. Because we manipulated the existing vector in place, we didn't declare temporary variables. This UI mockup shows our submission on the testing platform. The code clears the strict timing constraints and returns an accepted status. The time complexity is O of n, which represents linear time. We reversed specific sections of the array exactly once, meaning the processing time scales linearly with the size of the input. The space complexity is O of 1. We performed all operations directly on the original input vector, never allocating memory for secondary arrays. For a technical challenge, try building this exact 3-step logic in raw C. Use manual index swapping while loops instead of the built-in reverse functions. Mastering block manipulation allows you to process data in place. You bypass the slow, nested loops of a naive approach, resulting in code that scales effortlessly to any dataset.